Hello, Dr. White back again. This is the part two of our screencast series on the Open Intro Statistics sections 1.3 and 4. Last time we left off, I was promising to talk to you about confounding variables. Confounding variables are things that can appear in observational studies and can make it difficult for you to infer that a variable X causes a variable Y when you found out that the two of them are associated. So I want to give some examples and a clear definition of what we mean by confounding variables. It's going to differ a little bit from the definition that you see in the textbook. Rest assured that if I were to ask you on a test to define confounding variables, I would accept a textbook definition or this one. But I just want us to engage in this deeper exploration here. I think if you work with this way of looking at it, you'll come to a much better understanding of some of the limitations of observational studies. So we've talked about the idea of association and two variables being associated. Say you've got some variable X that's an explanatory variable for you in some research situation, and another variable Y that is the response variable in the situation. And you found that the values of X tend to go along with values of Y and vice versa in some way. That you found the two variables are related, associated in some way, or that they're dependent on each other. And you want to explain that association. How might we explain the association? That's the question we've got in your mind. What makes that association happen? Well, one way to explain the association would be that X causes Y, because we've already learned that if one variable causes the other, they have to be associated. So that's one possibility for why X and Y are associated. But there's another possibility. It could be that actually Y is causing X, contrary to your initial expectations where you were thinking about X as the explanatory variable. Maybe it's the other way around. Maybe Y is causing X. That would make them associated too. Or maybe there's a third variable. We saw the possibility of what we call a common cause in a previous example. And that was a third variable that did some work on some causal work on both X and Y. Here's a more general possibility. What if there's a third variable, call it Z up here, and I'm calling it conf for confounder, okay? So it's a different variable from X and from Y. And suppose that Z is associated with X. See the dotted lines? Associated with X, but not caused by X. So no possibility of an arrow running from X to Z. Now, there could be an arrow running from Z to X, where Z causes X. That's fine. And of course, if that happens, then Z would be associated with X, because whenever there's causation, there's association. But part of this scenario here is what we're assuming is that Z is associated with X, but not caused by it. Okay, so a third variable. Secondly, it's associated with the explanatory, but not caused by it. And thirdly, that it causes the response variable. So it's the cause of the response variable, or one of the causes, maybe only a partial cause, helps to cause the response. Three things. It's different from X and Y. Secondly, it's associated with X, but not caused by it. And thirdly, it causes the response variable Y. If those three things happen, then Z is called a confounding variable. That is the definition of confounding variable that I am offering to you here. A confounding variable is a third variable. It is associated with the explanatory variable X, but not caused by it. And it causes the response variable. If there's a confounding variable z out there, like this, then z is what's doing the causal work. And maybe x is not doing any causal work on y at all. It's just because it's associated with z that's doing the work, it's like it's along for the ride. And it gets to look like it might be causing the y, when really the z is doing the work of causing the y. You know? So this slide gives you that definition, not in pictures, but verbally, just as I did with my 3 fingers. And you see the 3 conditions right here. Third variable, associated with the explanatory but not caused by it, helps to cause y. And I'm saying that confounding variables are often going to be present in observational studies. And why do I say that? Well, let me just give you an example to show how easily this kind of thing can happen. Say you're doing an observational study, and you find that you're studying cars, okay? And you've got cars that maybe you watch them driving down a highway. And in every car, you record what color the car is. And you also record whether or not it gets a ticket by the end of its drive. And then you take all that data and you do some analysis, and you find that color of car and whether or not car gets ticket, 2 variables there, color of car, whether or not it gets ticket, you find those 2 variables are associated. In particular, let's say you find that the more brightly colored cars are more likely to, get tickets by the end of their drive on the highway than the drab colored cars are. Say you find that. Do your results allow you to infer, does this mean that the color of a car helped to cause the variable get a ticket or not? Is the color of the car a causal factor in whether or not its driver is going to get a ticket? Well, I think that you would not be justified in inferring that car color causes tickets, because you can think of many third variables that plausibly could be confounding factors, the ones that are actually doing the causing. For example, how about driving habits here, where I'm waving my mouse around this green third variable? The habits of the driver of the car. Does the driver of the car speed a lot, or aggressively swerve, in and out and around and cut off other cars and do things that, worry cops and get them to, chase you and give you a ticket? Clearly, driving habits is a third variable. And that's one of the things that a confounding variable needs to do. It's not your car color. It's not whether or not you get a ticket. It's a third variable. And secondly, I think it's quite plausible that driving habits of the driver are associated with the color of car that the driver has. Because if you think about it, drivers who love, to drive fast and aggressively may very well tend to like sports cars, which tend to be in sporty colors, like red and pink and yellow and all that kind of stuff. Whereas your staid and conservative, slow drivers, careful drivers may be quite content with these kind of off-white and gray and whatnot colored cars. And so driving habits and car color may very well be associated. Without the driving habits, being caused by the car color. I don't think it's plausible that like having a yellow car like makes you want to speed or swerve aggressively and cut people off and that kind of thing. Whereas having a gray one would somehow tame you. I don't think it works that way. So I think I've got a plausible argument here for the second condition in confounding factor, that this third variable is associated with the explanatory car color, but not caused by it. And then, third thing, very plausible that your driving habits cause whether or not you get a ticket. I think that's super plausible. People who drive fast and swerve aggressively are more likely to be seen by cops, and the cop gets worried and chases you down and gives you a ticket. So we've got all three conditions there for a confounding variable. So it could be that car color is doing nothing at all to cause getting a ticket, that it's just kind of tied through the association to the driving habits variable, and it's the driving habits that's getting the tickets for the dangerous drivers and avoiding the tickets for the conservative drivers. So if you find yourself maybe in a DA or just in real life doing data analysis out there, needing to think about confounding variables in an observational study, you're going to want to be good at explaining in words why something is a potential confounding variable. So here's a short paragraph that you might offer for this situation. The variable driving habits is a possible confounding variable. And then you got to back that up, and here you go. People who drive fast are more likely than others to prefer sports cars, which are more often brightly colored. That's you saying that this variable, driving habits, is associated with color of car. And then their fast driving also gets them lots of tickets. And so there you are saying that that third variable causes the response variable. So it's a little bit abbreviated. You're not like explicitly pointing out that the car color does not cause the confounder, which is part of the definition. But that's sort of so obvious here that you didn't really need to say it. But do get into the habit and practice when you think something is a confounder. Make the argument for why it meets all the conditions in the definition for a confounding factor, and then lay that out in a short paragraph like this. Now, experiments, which we discussed earlier, are not nearly as subject to confounding factors if they're well-designed experiments. And what we're going to see in the next screencast is why this is so, by thinking about how you do design experiments. And then we'll actually work with data from a specific experiment and kind of analyze it all the way through to the end. So I'll see you soon on that topic.